On one of the problems we have for homework this week, it deals with a ladder that looks, the picture is a little bit confusing, I think, but the problem wants you to simplify it as just a person sitting up on top of the ladder and a crossbeam coming here between it. Right? It looks like a big A. The individual has a particular weight, and this ladder sits on a surface, and the first question asks about what the force of the surface on each of the legs is. We need to be able to consider, the conditions for static equilibrium in order to determine the answers to the questions in this particular problem. Right? We know the sum of the net forces, sum of the forces is going to be equal to 0. We also know the sum of the torques, or the net torque, is going to be equal to 0 Newton meters. So we just need to apply this over and over again. I wanted to help you kind of identify what at least the forces are in this case. We have the force diagram for all of this ladder. We can't just drive it from a single particle anymore. We have a force here, the weight of the person down, the force of Earth acting on the person. We have a tension force. The brace here in the middle exerts a force on the right side of the ladder here, exactly in the direction that it's heading. So that's the tension. So it has a force, force of the bracer acting on the ladder. Similarly, there's another force on this side, right? The force of the brace acting on the ladder. And these are the only forces acting in the x direction. So we know that those must sum up and equal 0. They must be equal and opposite to each other. But there's definitely a tension within that brace. The only other force that it tells us that this is a frictionless surface, so there is no force in the x direction. Typically, when we have a ladder problems, I think some of the problems in your book, they don't. Sometimes the ladder's up against the wall, and the wall is frictionless, so there's no vertical force for that particular problem. But there might be a static force with the ground, so we would have some horizontal force for that particular case. Here we don't have a static frictional force with the ground, so there's no horizontal component. We simply have the normal force, the force of the surface on the ladder, and that is on both legs, right? It's equal in magnitude for both of these cases. So we need to be able to apply, so as I just said, the net force in the x direction must be equal to 0, and that lets us know that these tension forces are equal and opposite. The force of the brace on the right side of the ladder, minus the force of the brace on the left side of the ladder is going to be equal to 0. That may seem a little bit weird. I guess I'd put minus. That would mean that positive x would be going to the left, but I hope you can see that all this equation is really going to tell us is that the force of the brace on the ladder is going to be equal and opposite in direction, equal in magnitude for sure. So, that's really helpful. You should be able to write a similar expression for the net forces in the y direction that can tell you something that would be helpful for answering the first question.